Hello students, good morning. So today let us discuss DPP number 11 and then we will follow it with the new concept, right? So let's see. The total number of electrons that take part in bond formation in N2 molecule, right? So first of all, N2 molecule is a very important molecule in chemical bonding. We should know how to write its Lewis dot structure, then what type of bonding is there, sigma bond, then pi bonds, then hybridization, then structure of molecule. So many different points are there. For right now, let us discuss what is the Lewis dot structure of N2 molecule, right? Each nitrogen atomic number is 7. So with atomic number 7, it gets 1s2, 2s2, 2px1, 2py1, 2pz1. So 3 unpaired electrons are there. And in the valence shell, there are 5 electrons, right? So there are 5 electrons. So 3 electrons deficient it is, right? So what this nitrogen will do is it will combine with another nitrogen atom which is also requiring 3 more electrons. How they will be combining is these 3 unpaired electrons will share with the 3 electrons of the next nitrogen atom. That means it is something like nitrogen 1, 2, 3. These are the 3 unpaired electrons and this is the pair of electron, this one. This pair is this one. This is inertial. We are not involving these inertial electrons. They will not be participating in bond formation. And another nitrogen also will have the same electronic configuration, that this will be the lone pair, electron pair. The remaining 3 electrons are like this. Right now? Now this is the first one, second one, third one. So in this manner, N2 molecule is formed. So simply to write, it is like something in this way. This is the Lewis dot structure of a N2 molecule. Now he is asking total number of electrons that take part in a bond formation. So how many electrons take part in bond formation are 3 from one nitrogen atom and another 3 from another nitrogen atom. So this is the total 6 electrons are taking part in bond formation, right? So next, except dash gas, all other noble gases have octet in their valence shell. This already we know in inert gases or 18th group elements: helium, neon, argon, krypton, xenon, radon. Helium is the one which will be having duplet configuration. That means 2 electrons will be there in it. Remaining all will be having NS2, NP6. Octet configuration will be there, right? So therefore, you can say helium is the answer. Then next, 2 atoms of nitrogen form an N2 molecule by sharing dash pairs of electrons. That just before only we have discussed this one. 3 pairs. Total number of electrons are 6. 6 electrons in the form of 3 bonds, because each bond will be involving 2 electrons, right? So 3 pairs of electrons. The next, dash bond cannot exist independently. Which bond cannot exist independently? Pi bond cannot exist independently, because the first bond formed between any 2 atoms is sigma bond. A pi bond is formed as an additional bond to the sigma bond, but not independently. So it is the pi bond which cannot exist independently, or which has to always be along with a sigma bond only. But the sigma bond do not have that problem. It can exist independently, right? Then next, dash and dash orbitals can form pi bond. So which orbitals can form pi bond? The pi bond can be formed by such type of orbitals which are directional in nature. That means its lobes should be towards some direction, x or y or z axis, something like that. Suppose if we take a s orbital. In s orbital, it is a spherical. There is no direction. S orbital is a non-directional orbital. Therefore, S orbital cannot form pi bond. Only sigma bond can be formed. Whereas P and D orbitals are directional in nature. Therefore, bilateral overlapping or sidewise overlapping, they can form the pi bond. So, S and P wrong. So, S should not be there. P and D are possible. So, P and D are possible, and D and F, D orbital is possible, but F orbital we do not know to that an extent where F orbitals will involve in pi bond formation. So, maybe in future, if we come to know also by research and studies, we don't know, right? So, that's it. Then a sigma bond is formed by dash overlap of orbitals. Already we have discussed this one. Sigma bond is formed by axial overlapping and pi bond is formed by lateral overlapping. A sigma bond is formed by dash type of overlapping of orbital, that is axial or head-on. Axial or head-on. And pi bond lateral or sidewise. Okay. Then next. A pi bond is formed by dash overlap. That is what I was telling. Lateral or sidewise overlapping. These are all very, very basic questions, like, right? Just in a second you can tick mark the answer, right? N2 has dash sigma and dash pi bonds. So, what is the N2 molecule? N2 molecule is this one, right? N2 molecule is this one. So, in this molecule, this is the sigma bond, this is the pi bond, this is another pi bond. So, 1 sigma plus 2 pi bonds will be present in N2 molecule. So, carefully you have to see what is asked first. First sigma, then pi. So, 1 and 2, 1 and 2. So, this is the correct answer, right? Then, going to the next question, multiple covalent bonds exist in a molecule of multiple covalent bonds. Means 2 or more covalent bonds should be there, but that covalent bonds can be sigma bonds or pi bonds also, right? Na? So, multiple covalent bonds. So, F2 molecule is with a single covalent bond, H2 molecule is also with a single covalent bond, N2 molecule is with a multiple covalent bonds, then C2H6 is ethane. Ethane is also with a single covalent bonds. All are single covalent bonds. And here one more doubt you may get. Sir, multiple covalent bonds. Here also multiple covalent bonds are there. 7 bonds are there here. And here 3 bonds are there. So, this is multiple. This is also multiple. With respect to the question he is asking, actually question is incomplete to say. A multiple covalent bond between 2 particular atoms exists in which of the following molecule? Like that they have to ask the question, right? So, this can be considered as the answer because of the way the topic we are discussing. They are trying to check us to know what is a single bond and a multiple bond, a double bond or triple bond. Okay, na? The next. A pi bond is formed by lateral overlapping of, this is a lateral overlapping, this is also lateral overlapping, right? End-to-end overlapping, no. End-to-end overlapping, no. And see, for sigma bond, end-to-end overlapping of hybrid orbitals, this will match. For the pi bond, this will match. The reason is that if in a molecule hybridization happens on the central atom, these are the hybrid orbitals which will participate in sigma bonds formation. Sigma bonds formation, right? So, sigma bonds are formed by hybrid orbitals and pi bonds are formed by unhybrid pure atomic orbitals. So, this is what pure atomic orbitals. Therefore, this can be the answer. And in chemical bonding chapter, you will be getting what is hybridization, hybrid orbitals, types of hybridization, everything. Okay, na? Now, which of the following molecules deviates from the octet rule with respect to the central atom? Deviates from the octet rule. Octet rule is 8. Deviating from the octet rule is either it can be less than 8 or it can be more than 8 also in the central atom, right? In PCl3, on phosphorus, 5 valence electrons are there, plus 3 electrons it will share with a chlorine atom, so total 8. So this will not be the answer. Then sulfur, 6 electrons are already there, so 2 electrons will be shared with 2 electrons of hydrogens will be shared, therefore 8 electrons no. And again here also nitrogen with 5 electrons and 3 hydrogens, 3 electrons. Each atom, each hydrogen atom 1 electron, so total 8. So therefore this also is not violating, not deviating octet rule. And coming to XCF4, xenon valence number of electrons are 8, and from the 8, 4 of the electrons will be shared with 4 of the electrons of 4 fluorine atoms. So total it comes to 12 here, right? So 12 electrons here. So therefore xenon is deviating, it is going beyond octet in this molecule XCF4, xenon tetrafluoride, right? The next, the molecule that deviates from octet rule is, which molecule deviates from octet rule? That is what the just before also similar type of question we have discussed, right? So which molecule will deviate from octet rule? So here Na plus 8 electrons are there, Cl minus 8 electrons are there, beryllium 2 plus, Cl 2Cl minus, right? Or else if I write the structure in another way also, beryllium has 2 valence electrons. Let us assume this and these are the valence electrons of beryllium, and chlorine has 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. Another chlorine atom 1, 2, 3, 4, 5, 6, 7, right? Now between these two a bond will be formed, and between these two a bond will be formed, right? Now if you count, for chlorine 8 electrons are there, for this chlorine also 8 electrons are there, but the middle beryllium, if you see, there are only 4 electrons. So you can understand that beryllium is not maintaining octet configuration here, it is deficient of octet configuration, therefore this is the answer. And in MgO, Mg2 plus will have 8 electrons, and O2 minus also will have 8 electrons. In ammonia also already we have discussed 5 plus 3, 8 electrons will be there on nitrogen atom, right? Then going to next question, an expanded octet can be observed in the valence shell of the central atom in expanded octet. Deviation from octet configuration can be of 2 ways. One is going beyond 8, that is expanded octet, and having or being lower than 8, that is a deficient of octet, right? Here he is asking expanded octet, that means excess over octet configuration, excess over octet configuration. So in ammonia molecule there is no excess, 8 electrons are there, so this cannot be the answer. In CH4 molecule also 8 electrons will be there on carbon atom, therefore this is not the answer. And in PCl5, 5 valence electrons from phosphorus will share with the 5 valence electrons from chlorine, that this is becoming 10 electrons. So electron excess than octet. Coming to here, 2 from beryllium and another 2 will be shared from chlorine, that this is 4 electrons only. So this is a electron deficient. So this will become the answer for electron excess or expanded octet, and this is for electron deficient, right? He is asking about electron excess or expanded octet. Triple bond is not present in. I think in this question, the different molecules given, you may need to know the formula of the molecule and also its structure, right? First of all, cyanogen. What is cyanogen? As you are at home, you can search it also and can get the molecule. Cyanogen is Cn twice. Cn twice is a cyanogen, okay? Cn twice is cyanogen, and now this Cn twice structure is actually like this: C triple bond N, then another C triple bond N, and on nitrogen one lone pair, and on this nitrogen also one lone pair will be there. So in this manner cyanogen will be there, right? So here there is a triple bond as he is asking. So triple bond is not present in here. Triple bond is there. What about propyne? Propyne, YNE. In 9th and 10th you have IUPAC nomenclature of hydrocarbons, in which alkene, alkane, alkyne, like benzene, different compounds, and their naming are discussed, right? Propyne is this compound CH3, C triple bond CH. There is a triple bond here also. So this also cannot be the answer. And then coming to nitrous oxide. Nitrous oxide. What is a nitrous oxide? Nitric oxide is NO, whereas a nitrous oxide is N2O, laughing gas, right? So nitrous oxide, N2O. And now this is a nitrous oxide. If you see the nitrogen, another nitrogen, then oxygen, 1, 2, 5. If it is sharing with let me write the Lewis dot structure. So octet of this one will be completed. Then this is having 6 electrons plus 2 more electrons are there, and this is having again 6 electrons. If for oxygen also, if octet has to be completed, then nitrogen should donate this lone pair by day2 bond formation, and this should be like this. This will be the structure of N2O molecule, N triple bond N O. 1 lone pair on this one and 3 lone pairs on this one. So there is a triple bond in between 2 nitrogen atoms. Therefore, this is also possible. And a nitrogen dioxide. Nitrogen dioxide is nothing but NO2. NO2 is something like a N with one of the oxygen, double bond O, and 1, 2, 3, 4, sorry. An odd electron on nitrogen, and then to other oxygen it will donate the lone pair. So this is how the Lewis dot structure will be in NO2 molecule, nitrogen dioxide molecule. So in this nitrogen dioxide molecule, you don't find the triple bond between any 2 atoms, right? So this becomes the answer. The molecule which do not have triple bond, he is asking. Okay, na? So simple questions, all these are very basic, very basic. A molecule which contains only bonded pairs of electrons on the central atom. That means on the central atom there should be only bonded pairs. There should not be lone pairs or unpaired electrons. No other electron should be left over. All the electrons should participate in bond formation. That is the meaning, right? Na? So in this one, in H2O molecule, on the central atom there are lone pairs. So this cannot be the answer. In ammonia molecule also, on nitrogen there is a lone pair. So therefore this also cannot be the answer. And in BeCl2 molecule, on the central atom, lone pairs are there, but they are on the surrounding atoms. On the central atom, there is no lone pair. He is particularly asking, on the central atom, there should be no lone pair. So BeCl2 is the answer. And coming to BrF3 also, Br 1, 2, 3, 4, 5, 6, 7. 7 valence electrons are there, na? And each fluorine has 1 unpaired electron. So it will be forming 1 bond with each fluorine atom, right? So 3 sigma bonds are formed and 2 lone pairs will be there, right? So this is something like a Br with, this is a 1 lone pair, this is another lone pair, 2 lone pairs, then F, F and F. So in this manner, the 3 fluorine atoms will be with a single bond. So here also lone pairs are there. Along with the bond pairs, so lone pairs are also there. So this also cannot be the answer, right? So going to the next one, 16th question. A compound having a maximum number of bonded pairs of electrons. Bonded pairs of electrons, not bonded, not single electrons, bonded pairs of electrons in its molecule ethane, a compound having a maximum number of bonded pairs of electrons. In ethane, how many bonded pairs of electrons will be there? In ethane, bonded pairs are 1, 2, 3, 4, 5, 6, 7. Then in sulfur hexafluoride, how many bonded pairs are there? 6, right? Then in ammonia molecule, how many bonded pairs are there? 3, na? Already number of times we have taken this structure. 3 bonded pairs of electrons. And bromine pentafluoride, the name itself is indicating bromine pentafluoride, right? So in a BF5 molecule, sorry, BRF5 molecule, so bromine, then fluorine, 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 fluorine and fluorine. Bromine is a 17th group element, 7 valence electrons will be there. Among the 7, 5 are used here, remaining 2 will be present in the form of a lone pair. So 5 bonded pairs of electrons are 5 bonded pairs are there. 1, 2, 3, 4, 5. 5 bonded pairs are there. So altogether if you see 7, 6, 5, 3. So highest is in ethane and lowest is in ammonia, right? Or if they are asking order also, you can write increasing order, decreasing order, whatever they are asking, right? The next one, the number of electron pairs present in the valence shell of the central atom. Number of electron pairs present in the valence shell of the central atom in SF6 molecule, right? SF6 molecule, just before also we have drawn the structure, that is a S, F, F, F and F with 1 fluorine up, 1 fluorine down. So this is what square bipyramidal, right, or octahedral structure we say. So number of electron pairs present on the central atom. This is 1 electron pair, this is another electron pair, this is another electron pair, this is another electron pair, this is one more, this is one more. Total 6 electron pairs are present on the central atom in SF6 molecule, sulfur hexafluoride, right? The next, a molecule having a maximum number of lone pairs of electrons on the central atom is maximum number of lone pairs of electrons, on the central atom. Here 1 lone pair of electrons will be there, here 2 lone pairs will be there, here 0 lone pairs will be there, and here also 1 lone pair will be there, right? So therefore answer will become straight away H2S, right? H2S, hydrogen sulfide. The 19th question, among the following an electron deficient compound is. This also we have discussed many number of times. BCl3 molecule in which boron will be having only 6 electrons, 2 electrons deficient from the octet configuration, right? So last question, octet rule is not valid for the following molecule. For CO2 molecule octet is valid, O2 octet is valid, N2 also valid. It is the BF3 molecule for which octet rule is invalid, because in the previous, just before question also, we took the same question in which boron will be having in its trihalide, trifluoride or trichloride, BCl3, BF3, BBr3, etc. will be having only 6 electrons, 2 electrons deficient it will be having, right? So this completes a homework discussion, and now we will get into the new topic, okay? Idena? Chalo. So coming to, so in the last class we have discussed physical parameters topic, right? So 4 important physical parameters we have discussed, that is pressure, volume, temperature and energy, and in what units these physical parameters are expressed, and their interconversions also we have discussed, and which units are used in SI system and which units are used in CGS system also we have discussed, right? So now let us get into the next topic. We are left over with two more topics under CBC program. The one is basics of mole concept. One topic is the basics of mole concept and another one is BIN, basic inorganic nomenclature, right? So first let us go with basics of mole concept. Basics of mole concept. In basics of mole concept, actually mole concept is the initial or a starting chapter which is a foundation for entire physical chemistry of 2 years preparation in JEE or NEET, right? So it is a very important chapter, and within this mole concept, the initial the introduction part, which is very much important, right, for application in further chapters or further classes, will be discussed in this program, right? So first, going to the introduction of this chapter, this topic, matter, right? Something which has mass and occupies a space is matter, and depending on the physical state or chemical behavior, matter can be divided into two types. By physical state, it is like solids, liquids and gases. By chemical behavior, it may be pure substance or mixture, and within pure substance it can be a element or compound, and within mixture it may be a homogeneous or heterogeneous mixture. This classification everybody knows it, because this is discussed in the first lecture of CBC itself. The starting lecture of CBC, this point only was discussed, and along with this, what we need to discuss is first term. The most important terms in mole concept, frequently used in mole concept, are: first one, relative atomic mass. In short, can be written as RAM. RAM. Relative atomic mass. So what is this relative atomic mass, right? So when some atom, some substance, if it is existing in atomic state, we have to consider mass of atoms. If it is existing in molecular state, like oxygen gas is there, in O2 molecules it will be existing. Carbon dioxide gas, CO2, it will be existing. Helium gas, helium atom, like it will be existing. So depending on iron rod is there, iron atoms, first iron atom, second iron atom, third iron atom, fourth iron atom, like this. So depending on whether that substance is existing in atomic state or molecular state, accordingly it will be discussed, right? So first point is that from some substance, some atom is given, and this atom, what is the mass of this atom? If it is asked, suppose I go to market, I take some amount of potato, let us assume, and how can I pay to that? That should be weighed and it should be considered or given in terms of kgs, and then only per kg whatever cost is there, accordingly I will pay, I can pay, right? In the similar manner here also, initially what is done is when some element was given and to discuss its mass, then they were comparing the mass of this unknown element with some standard element mass. What was the standard element mass was, time to time it got changed. Initially it was a hydrogen atom, then oxygen atom also, then carbon atom also. You can take other atoms also actually, right? So carbon is now the standard reference in giving the mass of other elements. So what is a relative atomic mass is it gives the relatively how much heavier the given atom of an element in comparison to 1/12th part of C12 atom. He is not directly comparing with one single carbon atom. He is just comparing, he is just taking 1/12th part of C12 atom, C12 isotope atom as the reference. So reference is reference is 1 by 12th part of C12 atom. This is the reference. So this everybody have to remember this one first. This is the reference. What is the reference? 1 by 12th part of C12 atom. Like how pizza, regular small pizza is there. It will be made into 4 pieces, right? And then medium pizza is there into 6 pieces. Large pizza is there into 8 pieces, like that. So in the similar manner, he has taken one carbon 12 atom. Carbon 12, why I am indicating is carbon has a different isotopes, right? C12, C13, C14. 3 important isotopes it is having, but the most stable one is the C12 isotope. So now this C12 isotope, one atom is taken, and this single atom, let us assume it is divided into 12 pieces. Within these 12 pieces, one piece is our reference from now onwards, right? So that is what the 1 by 12th part of C12 atom. 1 by 12th part of C12 atom. Now, what is relative atomic mass is how many times బయటే వస్తుందా? కనపడదమ్మా కదా, కనపడదా? It is how many times an atom of given element is heavier than 1 by 12th mass of C12 atom. 1 by 12th part of C12 atom will be having some mass, right? So with respect to that mass, like how we are having now 1 kg. 1 kg means particular some mass will be there. So in comparison to that mass, 1 by 12th mass of C12 atom, how many times the atom of given element is there? How many times the atom of given element is there? That means it is actually just a number. Suppose I say hydrogen atom. It is 1 time to the C12, 1 by 12th part of C12 atom. Oxygen, 16 times heavier than 1 by 12th part of C12 atom. Let me write the example also. 1 oxygen atom is 16 times heavier than 1 by 12th of C12 atom. Therefore, I say that therefore relative atomic mass of oxygen is 16. Relative atomic mass of oxygen is 16. So just 16. In the similar manner, I say that RAM of sulfur is 32. What does it mean? Can you define? RAM, relative atomic mass of sulfur is 32, I am saying. Which means that one sulfur atom is 32 times heavier than 1 by 12th part of C12 atom. 32 times heavier. So some atoms can be there to how many times they are heavier, that number is only mentioned here, right? 5 times is heavier, 10 times is heavier, 30 times is heavier, 16 times heavier. Suppose phosphorus is there, 31 times heavier. Sodium is there, 23 times heavier. Magnesium, 24 times heavier. So that how many times it is heavier, that just that number, sometimes it can be like a 1.5 times heavier, 13.5 times heavier, fractional also possible, right? But just the number it is, that is what relative atomic mass. It will not have any units. It will not have any units. So just a number. Does not have units. Does not have units. Relative atomic mass, right? So similar to relative atomic mass, I can say relative molecular mass also. Relative molecular mass also, right? So relative molecular mass is second term we are discussing. Relative molecular mass. RMM. So similar to relative atomic mass, you can just recognize, identify what can be relative molecular mass. Relative molecular mass is how many times one molecule of a compound is heavier than, again same, reference is same, 1/12th part of C12 atom. How many times one molecule of an atom, of a molecule, how many times one molecule of a substance is heavier than 1/12th mass of C12 atom. Reference is atom only, right? C12 atom. So this is relative molecular mass. Suppose if I say example, as an example, right? As an example, RMM of CO2 molecule is, RMM of CO2 molecule is, RAM of carbon is 12, RAM of first oxygen is 16, RAM of second oxygen is 16. So altogether it comes to 6 plus 6, 12 plus 2, 14, 4. So RMM will become 44. What is the meaning of this 44? Is one CO2 molecule is 44 times heavier than 1/12th part of C12 atom. Understanding? One CO2 molecule is 44 times heavier, right? RMM of O2 is 32 times. RMM of H2 is 2. Means one H2 molecule is 2 times heavier than 1/12th part of C12 atom. So in this manner, suppose if I take sulfur dioxide, SO2 RMM. Bolo, what can be the RMM of SO2? Can you say? Sulfur RAM is 32 and each oxygen 16. 16 into 2, 30. 32 plus 32. So it is the 64 times. So one SO2 molecule is 64 times heavier than 1/12th part of a C12 atom. 1/12th part of C12 atom, right? RMM is sum of RAMs of all atoms. RMM is sum of RAMs of all the atoms within that molecules. So, hope you have understood RAM and RMM. Now, let us go to the next important term, that is atomic mass unit. If you observe here, whether I am discussing RMM or RAM, RAM also you see, there are no units. It is just a number. There are no units. Till now, there are no units. But right now, what we are doing is whatever the 1/12th part of C12 atom, that mass, whatever we are taking as reference, that itself will be considered as one basic unit. That is what is called as AMU, atomic mass unit. Right? This atomic mass unit, let us discuss now. Right? AMU, atomic mass unit. And now this atomic mass unit, it is the mass of mass of 1/12th part of C12 atom. 1/12th part of C12 atom. It is the mass of 1/12th part of C12 atom. Right? This is the AMU. And AMU, it is also denoted as unified mass U or Dalton D. So, AMU or U or D, all will be same. All will be same only. And now, what is the mass? This, it is okay. It is the mass of 1/12th part of C12 atom. But how much it weighs? That is also we should know it, right? Suppose 1 kg of banana, 5 kgs of potato. Right? 1 kg of banana we don't take, right? So, that is 1 dozen of banana. But in Kerala, in kgs banana will be given. Okay. So, anyway, so 1 kg of potato, 5 kgs of mango, like in a different ways. So, some particular value will be there, mass will be there. Here also, mass of 1/12th part of C12 atom will have a exact actual mass. 1 AMU is equal to 1.66 into 10 to the power of minus 24 grams. This is the mass of 1 AMU, or 1.66 into 10 to the power of minus 27 kgs. This is the very important point. You have to remember, memorize this value. What is the value of 1A? What is the mass of 1 AMU? 1.66 into 10 to the power of 24 minus 24 grams. Understanding? So, this is AMU. 1 AMU is equal to 1 unified mass is equal to 1 Dalton is equal to 1.66 into 10 to the power of minus 24 grams. Understanding? Anna? So, this is AMU. Now, going into next important term, that is the fourth one, mole, right? Not a mole which is present on skin, right? In certificates, it will be given. Sorry. In certificates, it will be given. 1 black mole on the right side of the neck or left elbow for identification purposes, right? So, it is not like that. The mole is an SI unit to express some number, right? Suppose when we go to market, same example let us take. We take 1 dozen of bananas. 1 dozen of bananas means how many? 12. 1 dozen is equal to 12 because that 12 number is already rounded off or fixed into 1 dozen. 1 dozen means 12. 1 century means 100. Like that, there is one particular number which is fixed into 1 mole. But what is the reason for fixing this one? Particular number into moles is, particularly mole is a term used in a chemistry point of view or physics point of view, because when we are taking the reactants and reagents and you are doing the reaction, the atoms or molecules are very minute that you cannot see by normal eye. Even in a normal compound microscope also you cannot see them, right? That much small. You very simple example, you take just one drop of water. Within that itself there will be trillions and trillions of water molecules will be there, right? I take a balloon and pumped a little amount of gas, that itself will have enormous number of oxygen, carbon dioxide and other gas molecules. Like these are very small entities. Therefore, you cannot do the reaction by taking 10 carbon atoms reacted with 5 hydrogen atoms. Like that you cannot do the reaction, because the moment you take a very small sample also, it itself will contain large number of atoms. Even trillions is also very small number in comparison to these atoms or molecules we handle. So if we are handling these many large numbers, then every time you cannot write 100 trillion atoms of carbon is reacted with 200 trillion oxygen atoms, then we got these many trillion carbon dioxide molecules. Like that it becomes very difficult and confusing and impossible in doing the calculations also. It becomes very messy. So for this reason what they do is like suppose now in the similar way 60 bananas are taken. Simply you will pay for 5 dozens of banana. You will say 5 dozen banana I have bought, right? Or 10 dozen banana I bought, or 1 box banana I bought, right? So in the similar manner, that is a 20 dozen generally will come in 1 box. So in the similar way, here also, as we are handling with a very large number of atoms or molecules or ions or electrons, protons, anything, very large number to say, right? So these are grouped into, taken into one simple unit, one simple SI unit, that is only mole, right? Now, what is a mole? Same like a 12 indicates, 12 banana is 1 dozen banana, 12 apple is 1 dozen apple, 12 pencils is 1 dozen pencils, 12 books is 1 dozen books, or 6 books is half dozen books. In the similar manner, there is a particular number of any object. It may be atoms, molecules, ions, electrons, protons, nucleons, apples, banana, pen, pencil, eraser, whatever it is. So, but that many number is considered as 1 mole. If half of that particular number is there, you will call it as a half mole. If double the number of that particular number is there, you will call it as 2 moles, 3 moles, 10 moles, 100 moles, like that. But whatever the chemical reactions we do in laboratories, that is handled in terms of moles only. Understanding the point? In terms of moles only. So now a mole one mole of any objects right? Like they may be atoms, molecules, electrons, nucleons, apples, pens, books, etc. of have 6.023 into 10 to the power of 23. These many, if these many particles are there, objects are there, then you can consider it as 1 mole, right? 1 mole. 1 mole is equal to 6.023 into 10 to the power of 23. 10 to the power of 23, right? So you can understand how many zeros are there, how much big this number is. So 1 mole is 6.023 into 10 to the power of 23. Sometimes you see, for calculation purpose or in a different sources, it may be present like this. 6.023 may be present as 6.02 only, or sometimes even it is simplified into 6 into 10 to the power of 23, right? So you will be getting answer, right? Very nearer answer only you will be getting, because in comparison to 10 to the power of 23, whatever the rounding off you are doing is negligible. Understanding? So it can be given in any of these ways, and sometimes it is also given like 6.022 into 10 to the power of 23. Regularly this is the one who will be following. 6 into 10 to the power of 23, so becomes easy for divisions and multiplications, right now? So this is one thing. As the point has come, there is one small thing I need to tell you. Like yesterday we did JEE Advanced test paper live paper discussion in our YouTube channel, Resonance Hyderabad YouTube channel, and what the subject experts were saying, like many of the students were taking a lot of time. Maybe they are reaching to the answer, but they are taking a lot of time in calculation part, that is addition, multiplication, subtraction and division, right? So these are the basic functions which you are studying from, which you are practicing from childhood, right? But now the time has come to make it a more and more rigorous exercise. So especially multiplication tables you should know, right? By visualization you should know it, and then how to calculate fractions, then decimals, then square roots, like this. These points also will be very important. So overall to say, if maths, physics and physical chemistry you have to score better, so that is possible only when you score it in a lesser time duration. If you are taking 10-15 minutes for a question, even you are getting the answer also, it is not useful, right? So practice well. Now this is the best time for you in summer vacation to become strong in your basic calculations, right? So that you can build up, or how fast you are, that much better advantage, edge will be there for you, right? So this is basically what is mole. Mole is any objects or any particles of 6.023 into 10 to the power of 23. If these many are there, you can consider as mole. Suppose somebody has given me 12 into 10 to the power of 23. 12 into 10 to the power of 23. What did this becomes? 6 into 10 to the power of 23 is 1 mole. Then 12 into 10 to the power of 23 will become 2 moles. 2 moles, right? Double is there, na? 12, na? Double is there. And suppose it is like a 3 into 10 to the power of 23 is there. So this is what? Half mole. Or 1.5 into 10 to the power of 23 is there. This becomes 0.25 mole or 1/4 mole. So in this manner, in different ways it can be given, but one thing you have to understand is mole means these many particles should be there. 6 into 10 to the power of 23 particles should be there. And this 6.023 into 20 to the power of 23, this number is given by Avogadro. I call it as a Avogadro number. The number itself is given a name called Avogadro number, right? So if Avogadro number of particles are there, that will be equal to 1 mole. Avogadro number of particles are there. Avogadro number means nothing but 6.023 into 10 to the power of 23 particles are there. These many electrons, protons, anything are there. So that is equal to 1 mole, right? So Avogadro number is denoted by Na or N naught, or sometimes N small a also. In different ways it can be given, but basic you have to understand what is the basic point here. Okay na? So hope you have understood what is a mole, right? So now let us get into the next point. So I will go to the next page, right? Next point, that is a gram atomic mass and gram molecular mass. Gram atomic mass, so that is a fifth one, right? GAM, gram atomic mass, is, it is the mass of it is the mass of 1 mole of atoms in grams. It is the mass of 1 mole of atoms in grams. Suppose you are given with 1 mole atoms. What does it mean? Avogadro number of atoms, 6.023 into 10 to the power of 23 atoms are given to you. So all these atoms together will be weighing to some grams or kgs, na? So that is gram atomic mass, mass of 1 mole of atoms, Avogadro number of atoms, right? So GAM of oxygen, oxygen, right? GAM of oxygen. So what is this GAM of oxygen? What is the mass of 1 mole of oxygen atoms? GAM of oxygen is mass of mass of one mole of atoms, right na? Or mass of 6.023 into 10 to the power of 23 atoms of oxygen, okay na? Or mass of 1 oxygen atom into that many atoms, 6.023 into 10 to the power of 23. Mass of 1 oxygen atom is, mass of 1 oxygen atom is atomic mass of oxygen into 6.023 into 10 to the power of 23. Now atomic mass of oxygen is 16 AMU. 16 is the relative atomic mass into AMU. Atomic mass is relative atomic mass into AMU, right? So this is a one standard point, as already we have discussed, right now. So now this one, right? So now 16 AMU into 6.023 into 10 to the power of 23. And what is the mass of 1 AMU? 1.66 into 10 to the power of minus 24 grams into 6.023 into 10 to the power of 23. Surprisingly, if you see 1.66 into 10 to the power of 24 minus 24, 1.66 into 10 to the power of minus 24 is equal to 1 by 6.023 into 10 to the power of 23 only. This is another point you can remember. That means this is nothing but, this value is nothing but 1 by 6.023 into 10 to the power of 23. So when you substitute this one here, this and this will get cancelled. That means this and this are getting cancelled and you will be left over with 16 grams. That means what you can redefine gram atomic mass is, it is the atomic mass expressed in grams. Atomic mass expressed in grams is gram atomic mass, right? Atomic mass expressed in grams is gram atomic mass. So in this manner, gram atomic mass can be given. Now you see relative atomic mass of oxygen, or I will go to the next point, next page. RAM, relative atomic mass of oxygen is 16. AM of oxygen is 16 AMU. GAM of oxygen is 16 grams. So understand RAM, AM, GAM. Got it? So going to the next point, that is sixth one, gram molecular mass, right now? GMM, gram molecular mass. How do you define gram molecular mass? Same like a gram atomic mass. It is molecular mass expressed in grams. So one definition. Another definition, another way of telling is mass of 1 mole of molecules. Mass of 1 mole of molecules, right? Molecular mass expressed in grams, or mass of 1 mole of molecules. Mass of 1 mole of molecules is gram molecular mass. Suppose you say GMM of CO2 is, GMM of CO2 is mass of 1 mole of CO2 molecules. Or this also can be written in another way as mass of 1 CO2 molecule into 1.66 into 10 to the power of 23. Right? Mass of 1 CO2 molecule is mass of 1 CO2 molecule is 44 AMU into 6.023 into 10 to the power of 23. This is nothing but 44 into 1.66 into 10 to the power of minus 24 grams into 6.023 into 10 to the power of 23. This already I told you, this value is nothing but 44 into 1 by 6.023 into 10 to the power of 23 grams into 6.023 into 10 to the power of 23. Just for your understanding I am telling, otherwise everybody of you have already know it. So what is left over here? 44 grams. So gram molecular mass of carbon dioxide is 44 grams. 44 grams, or I will write this here, 44 grams. 44 grams. Now, relative molecular mass of CO2 is 44, right? Molecular mass of CO2 is 44 AMU. Gram molecular mass of CO2 is 44 grams. So, in this manner, in different ways you can give. Last one point here, that is a molar mass is equal to mass of 1 mole. Mass of 1 mole. Mass of 1 mole of what? It may be atoms, bananas, apples, watermelons, pencils, books, atoms, molecules, ions, anything. Understanding? So, mass of 1 mole. So, molar mass is itself is GAM or GMM. Molar mass, mass of 1 mole. If that is atoms, then it itself is GAM or GMM. Understanding? So, this is one point we have to discuss. According to the planner, we have to discuss today. Hope you have understood this concept, right? So, in the tomorrow's class, we will be discussing DPP 12 and then we'll further move into mole concept, other new information. So, hope you have enjoyed this class. Myself, MVK sir. And my phone number is for WhatsApp. If you are having any doubts, you can message me 8142424141, right? So, you can be in contact. And next class, physics. Starts at 10:20 AM, right? So, hope you have enjoyed this class. Take a small break and then you will be having a physics lecture, right? So, all the best. Bye.
Good morning to all of you. Yeah, let us continue. Yesterday classwork I have completed. Now, let us continue with homework. External forces are. Now, you know that the initial state of the body can be changed by net external force. Now, external forces always balanced? No. If it will always be balanced, means net force will be 0, then body cannot move. Never balanced, it may be balanced. So may or may not be balanced will be the answer. Answer will be may or may not be balanced. Clear? Let us move to now next question. When we talk of a force acting on a body, when we talk about a force, we are not knowing which kind of force it is. When we are exerting the force, usually initial state of the body may be changed. So when we talk about a force acting on the body, it means that body will be or may be accelerated. So it usually means unbalanced force. Move to next question. Which of the following classes of forces is different from the others? Pulling of a cart. Macroscopically, it is electromagnetic. Stretching of a coiled spring. Again, macroscopically, it is electromagnetic. Kicking of a ball. Muscular, it means also it is electromagnetic. I have told you, basically we have only 3 types of forces: gravitational force, electromagnetic force, and nuclear force. One more weak of Fermi force is there. Abdul Salam, Pakistani origin, a scientist long ago has told it is a part of electromagnetic force. So all A, B, C, we are finding they are under the category of electromagnetic force. So fourth one will be the answer, weight of the body. Weight of the body, it is a gravitational force. Now, move to next. Which one of the following basic forces is a short-range force? They have given you electromagnetic, gravitational, and nuclear. When you talk about nuclear force, it is acting only in between the nearest nucleon. Yeah? Due to that only you are getting radioactivity. When mass number will exceed 206, okay, no? Coulombian force may start dominating over nuclear force. So short range force is nuclear force. Answer will be C. Move to next question number 5. Which force exists between a neutron and a proton kept at a large distance? If neutron and proton will be kept very close to each other, then only one force will act, that's nuclear force, right? If they are kept at a very large distance, you know, neutron is a neutral particle. Proton is positively charged particle, but in between proton and neutron, there will be no electromagnetic or electrostatic force. So answer will be gravitational force. It is charge independent. It will not depend upon the charge. So the force which will act in between neutron and proton when they are being kept at a very large distance is gravitational force. Let us move to next question. When a teacher at Resonance Hyderabad forces his students to study well to crack competitive exam, first thing, my dear children, we never force, okay? We are in resonance, we are making our resonites to understand the importance of education. You see, you can force a horse to come near the source of water, but can you force the horse to drink water? No, na. We never force any child. Our children, our resonites, they themselves study better. Okay, but suppose a teacher is forcing you to study. This is what kind of force? It is a matter of physical quantity, right now. So it will not come under physics. It is not under the category of physical quantity. So whatever answer you will be telling, it will be wrong. It is a metaphysical. So they have given you, let us see, alternate an electromagnetic force, a gravitational force, a nuclear force. All these are physical. Answer will be, it is not a physical force. Clear? Let us move to next question. Now, the force between Earth and Moon is, you know, the old people in your house also, grandpa would be there, okay, no? They are getting rheumatic pains, pains in joints. I also in old age, sometimes on full moon day or Amavasya day, in joints we are feeling pain. Okay, no? You know, in sea tide is coming. Okay, no? All are due to gravitational pull of moon on the water on the surface of Earth. Right? The force between Earth and Moon guaranteed will be a gravitational force. Right? Let us move to next question. Within the short range of particles, which is correct among the following? The nuclear force is stronger than the electromagnetic force. The nuclear force is stronger than the gravitational force. Electromagnetic force is stronger than gravitational force. All are correct. Nuclear force is 10 to the power 39 times. I'm not telling 39 times. 10 to the power. When you say 10 to the power 3, means on 1, 000 you are keeping. 1,000 times it becomes only 10 to the power 3. Think 10 to the power 39 on 139 zeros you keep. So much stronger nuclear force is. Okay, no? The nuclear force is 10 to the power 39 times stronger than gravitational force. Right? And 1,000 times stronger than electromagnetic force. So, the strongest among all the three forces will be nuclear force. So, here your answer will be all are correct. Clear to you? Now, let us move to next question. When a body remains stationary, when a body is at rest, only two things will happen. Either no forces are acting, okay, no, or many forces would act, but vector sum of all the forces must be equal to 0. So here, answer may be there is no force acting on it. The forces acting on it are not in contact with it. The combination of forces acting on it balance each other. The body is in vacuum. So when a body remains stationary, I feel multiple answers are coming. There is no force acting on it. That's also correct. There is no force acting. Body may be at rest. Here, among these four, the combination of forces, actually combination we should not say, we will say vector sum of all the forces acting on the body. Okay, no, must be equal to 0. So if we select one among these four, my answer will be number C. Let us move to next question. An object moving with constant velocity must, according to Newton's first law, what you have told, a body may be at rest or it will be moving with constant velocity unless it is acted upon by a net external force. Then object moving with constant velocity must have a net force acting on it, eventually stop due to gravity, have no force acting on it, have no net force acting on it. Answer will be have no net force acting on it. Answer D. Let us move to next question. A body is said to be in translational equilibrium. The resultant force on it is 0. It is at continuous rest. It is in uniform motion. All correct. Now, translational equilibrium means net force acting on the body is 0, or body will be at rest according to Newton's first law. The first alternate they have given you, the resultant force on it is 0. That is correct answer. It is at continuous rest, means it is at rest. When body is at rest, no net force is acting, same statement. It is in uniform motion. Uniform motion means velocity remains constant, and velocity will remain constant when resultant force acting on the body will be 0 or no net force will be acting on it. So, A is correct, B is correct, C is correct, answer all correct. So, answer here will be all correct. Now, let us move to next question. A particle is in a straight line motion with uniform velocity. A force is not required. According to Newton's first law, if a body is moving along a straight line path, right now, if a body moves along a straight line path with constant velocity, it means that no net force is acting on it. Body will like to continue its initial state. And initial state is that of constant velocity. So here they say you to increase the speed, to decrease the speed, to keep the speed constant, to change the direction. For changing the direction, also you need a force. So answer for this is to keep the speed constant. Okay, no? I think that they should say to keep the velocity constant. Anyhow, next, on which factor does the inertia of a body depends? Further, why to read? Inertia of translatory motion depends upon only one quantity, and that quantity is mass. Right now, inertia depends on mass. Mass gives the measurement of inertia, inertia of translatory motion. Moment of inertia will give the measurement of inertia of rotatory motion. Right now, here inertia means inertia of translatory motion, so mass will give the measurement of inertia. They say you on which factor does the inertia of a body depends, which has more inertia, a cricket ball or a rubber ball of the same size. We were playing cricket with a rubber ball in childhood, right now? If here they are talking about really a cork ball or deuce ball, that is heavier than rubber ball. You remember? When you were a small child, you were playing cricket with rubber ball, na? As you have grown up, you are playing with real cricket ball. the real cricket ball is heavier than rubber ball na? It means that mass of cricket ball is more than mass of rubber ball. Mass gives measurement of inertia. If mass is more, inertia will be more. Cricket ball has more mass, so its inertia is more. So answer here, cricket ball has more inertia. Clear to you? Let us move to next question. The inertia of an object tends to cause an object to increase its speed, to decrease its speed, to resist a change in its state of motion. According to Newton's first law, if a body is at rest, body will like to be in the state of rest. If a body moves with constant velocity, body will like to move with same constant velocity. Right now, the answer for this is to resist a change in its initial state of motion, either a state of rest or motion along a straight line path with constant velocity. So answer for 14 will be to resist a change in its state of motion. Let us move to next question. When a train stops suddenly, passenger in the running train feel an instant jerk in the forward direction. I have told you yesterday, to find what kind of inertia body has, you have to consider the initial state of the body. So when a train stops suddenly, before stopping, train was moving now. Train was moving. And then you have retarded and all of a sudden you have stopped it. The initial state was that of motion. So it will be a case of inertia of translatory motion. Let us see what alternate they have given. The back of the seat suddenly pushes the passenger forward. Inertia of rest stops the train and takes the body forward. The upper part of the body continue to be in the state of motion, whereas lower part of the body in contact with the seat remain at rest. Answer is C. Why? When train will be stopped, lower part of the body is in contact with the train. The lower part of the body will come to rest. Upper part of the body, due to inertia of motion, will like to continue its state of motion. So the person will feel an instant jerk in the forward direction. You will be feeling the same thing in aeroplane when it is landing. Okay, no? Many of you people are very rich. You people have traveled by train. Okay, train, aeroplane. Okay, no? So when aeroplane is landing, in train you may feel, may not feel. Right? No? But in aeroplane, guaranteed you will feel. When it is landing, retardation is very large. The best way is there, keep your body in complete body in contact with the seat. Already seat belt is there. Okay, no? But at the same time, if your whole body will be in contact with the seat, you may not be getting that much jerk on upper part of the body in forward direction. Correct? So for this question, your answer is the upper part of the body continues to be in the state of motion, whereas lower part of the body in contact with the seat remains at rest. Not remains at rest, it comes to rest. Let us move now to next question. A man getting down a running bus, same thing will happen. When a man is getting down from a running bus, what will happen? The moment he will jump out, it has happened with me, so I am telling you. Yeah. Actually, once I was traveling by bus, and where is my home? Their stoppage is not there. So people usually, bus a bit, they will make it slow, and people will be jumping. I also thought to jump. The laws of physics had applied on a physics teacher only. The moment I have jumped out, the feet which has come in contact with the road had come to rest. But upper part of the body was thinking it is still in bus. It was moving in forward direction. So what will happen? If lower part of the body will come to rest and upper part of the body will like to move, you will fall in forward direction. So let us see what are the answers given. Due to the inertia of rest, road is left behind, leave it. Due to inertia of motion, upper part of the body continue to be in motion in the forward direction, while feet comes to rest as soon as they touch the road. Answer, due to inertia of motion. Initial state was that of motion. Right? No. Because initial state was that of motion, so man, after jumping out on the road, is falling in the forward direction. So answer is B. Let us move to next question. A boy sitting on the topmost berth. A boy is sitting on the topmost berth in the compartment of a train which is just going to stop on a railway station, drops an apple aiming at the open hand of his brother, sitting vertically below his hand at a distance of about 2 meters. The apple will fall. Now, boy is sitting on the topmost berth, right? And train is going to stop. The motion of train is retarded. The moment when he had dropped apple or ball, it will have initial velocity in horizontal direction, the same velocity, whatever velocity at that moment train will have. Okay, no? And it will continue. But what will happen to the train? Train is retarding. So its velocity is going on decreasing. So in horizontal direction, velocity of train is decreasing, whereas apple or ball will continue to move with its initial velocity in horizontal direction. So it will fall in forward direction. So here they are telling you A is wrong, slightly away from the hand of his brother in the direction of motion. So slightly away from the hand of his brother, opposite. Answer will be slightly away from the hand of his brother in the direction of motion of the train. Is it clear to you? Now, all are concept-based questions in your homework, right now, and all are based on Newton's laws of motion. Let us move to next question. I am now on question number 18. When a bus suddenly takes a turn, inertia of direction. When a bus suddenly takes a turn, the passengers are thrown outward because of inertia of motion, oblique direction, acceleration, speed of motion. No, I have already told in the beginning, this is due to inertia of direction. So answer will be inertia of direction. Let us move to next question. What happens to the inertia of an object when its velocity is doubled? Okay, many people think that when we are doubling the velocity by keeping mass constant, guaranteed linear momentum will be doubled. Linear momentum is mv, mass constant, velocity you have doubled, so linear momentum will become m into 2v, linear momentum is doubled. Clear? But inertia depends only on mass. Many may not agree, but I am telling you, inertia depends only on mass. If you are changing the mass, then only inertia will be changed. So they are asking you, what happens to the inertia of an object? Your linear momentum will be doubled. But what about inertia? They have not spoken about mass. We'll assume that mass is constant. If mass is constant, guaranteed inertia will remain constant. Is it clear to you? Understood? All theory questions related to your homework I have completed. Now, further again we will continue. Before that, let us study two topics. First, I want to speak about, in brief, not in too much depth, okay, no, just basic concept related to impulse I want to give you. Okay, no, I have told you that F, first I am talking about impulse. Okay, no. Now, F is dp by dt. Okay, no. Now, multiply. F dt is dp. Okay, no. When a large force acts on a body for a very short interval of time, then that force is known as impulsive force. The product of force and the time for which it is acting on any body, that is known as impulse. F into dt is known as impulse. So you will have impulse, it is a vector quantity, it has direction of force, and this is also equal to dp. dp is change of linear momentum. So you can say it is equal to change of linear momentum. Change of linear momentum of a body. Clear to you? The impulse, two definitions you have. This is also known as impulse momentum theorem. Simple, it is definition, but they are naming it as impulse momentum theorem. Impulse has lot of importance. It is product of force and the time for which the force has acted on the body. Impulse is defined as change of linear momentum of the body. Okay, so many examples you have in day-to-day life. You people are loving to play cricket. If you are doing fielding, you are catching the ball. How you are catching the ball? All of a sudden you are not stopping. You are pulling your hand in backward direction. Why? Your main target is to stop the motion of ball. So final linear momentum is 0. And with whatever velocity ball is coming, that will give initial linear momentum. The change of linear momentum of ball is a constant quantity depending upon velocity of ball. Right? So F into time, that is a constant quantity. If you pull your hand in backward direction, time for stopping the ball, you are increasing. When you will increase the time, F into dt or F into t is a constant, right? So when you will increase time, F will be decreased. Okay, so you will have to apply a smaller force, relatively smaller force, to stop the motion of ball. So what will happen? Ball also will exert a lesser force on your hand. You will not be hurt. And in car, in bike, okay, no, they are giving springs, shock absorber. Okay, no. As much costly car is, that much better shock absorber would be. Okay, no. Why they are providing you shock absorber? They are providing shock absorber only for F dot dt. dt increase, F will be less, you will get less jerk. Clear to you? Just few examples I am quoting in front of you for the impulse. You have jumped. Jump on sand. Okay? And jump on a concrete floor, hard floor. You will be hurt more if you are jumping on hard floor. Why? Again, there, time taken to stop the motion of your body is less, so F will be more, you will be hurt more. If you are jumping on sand, what will happen? Time will be increased. Time for stopping the motion of your body will be increased, so force exerted will be decreased, you will be less hurt. Clear to you? So many examples you have related to impulse. When you are taking any example of impulse, always in brain you keep force into time for which force has acted, that is equal to change of linear momentum. To stop the motion of any body, change of linear momentum will be constant. That will be simply equal to initial linear momentum because you want to stop. So final linear momentum is 0. So change of linear momentum will be equal to minus of initial linear momentum, a constant. So F into t, a constant. Now F into time, when it is constant, if you are increasing t, F will be decreased. Right now, if you decrease t, F will be increased. That is the way to find the reasoning answer for any question based on impulse. Clear to you? Understood now? So now, if I plot a graph, force versus time, if a large force has acted for a very short interval of time, your graph will be like this. Okay, no? Now, whatever is this area, F into t, now you are telling impulse, the area of time you have taken on x-axis, force acting on body you have taken on y-axis, the area of ft graph will give you the value of change of linear momentum or impulse acted on the body. Did you understand? Yeah? In more depth in collision chapter, I will be talking about impulse. Here also two things will be there. Before collision, after collision. Before collision, the time for which body would be deformed. And after collision, time for which body will recover its original shape or size. You are playing cricket. You are heating the ball. Before heating, ball is appeared to be spherical. After heating, again when you see the ball, it will appear to be spherical. At the time of collision, for a very, very short interval of time, the shape of the ball will not be spherical. Where it comes in contact with the bat, there it is being flattened. But it's for such a short duration that that deformation you cannot see. Okay, no? If you have a camera where you are increasing the speed, means slow, you are making, and then in that slow movie you see, you'll be finding that ball is deformed. Okay, no? The time for deformation and time for recovery, line of impact, line of impulse, all these things you will be learning in more depth when you will be learning collision. I told you collision is a separate unit for our IIT. Okay? At this time, just basics in mind you keep. What is impulse? Impulse is F multiplied by time. Which time? The time for which force has acted on the body. Impulse is equal to change of linear momentum of the body. Change, always we take final minus initial, means final linear momentum of the body minus initial linear momentum of the body. Tell me, understood? Some examples I have quoted for impulse. Okay? Further, impulse, line of impulse and all, line of impact, we will be studying in collision unit. Clear to you? If you understood this, then now let us go for conservation of linear momentum. Now, we want to learn conservation of linear momentum. Linear momentum. We want to learn about this, right? In IIT, it is a separate unit. You remember this, okay? So suppose this is a surface, frictionless. I have two ball. M1, M2, moving with U1, moving with U2, U1 greater than U2. This is a fixed surface. This surface is fixed. Since U1 is greater than U2, U1 minus U2 will be known as relative velocity of approach, right? Since U1 is greater than U2, guaranteed from back M1 will hit M2. So after some time, M1 and M2 will collide. This is M1, this is M2. M1 will exert force on M2, and according to third law, the equal but opposite force will act on M1. So on this, force acting on 2 due to 1, and this side, force acting on 1 due to 2. And both will be equal. F21 will be minus F12. Minus sign because directions are reversed. Just Newton's third law. Okay, no? Now, what you consider according to Newton's third law? Every action has equal but opposite reaction. If M1 will exert force in this direction, equal but opposite force will acting on it. The force acting on 2 due to 1 will be equal to minus of force acting on 1 due to 2, Newton's third law. After that, let us suppose these two balls are moving with, this is m2, moving with velocity v2 and v1. Here you take v2 is greater than v1. If v1 will be greater than v2, again it will hit. So, for separation, we are taking v2 greater than v1. So, u1 minus u2 is relative velocity of approach, and v2 minus v1 will be relative velocity of separation. We will not require this here. Okay, no. In collision unit, when I will speak about perfectly elastic collision, you'll be finding that relative velocity of approach will be equal to relative velocity of separation if collision is perfectly elastic in one dimension. At this time, we are interested only in principle of conservation of linear momentum. When no net external force acts on a body, when no net external force will act on the body, total linear momenta of mutually interacting bodies will remain constant. Here you have taken two bodies, m1 and m2, moving with velocities u1 and u2. Before collision, what is linear momentum? It is m1 u1 for first body, m2 u2 for second body. Total linear momentum is m1 u1 plus m2 u2. Yes or no? Understanding now? Before collision, what is total linear momenta? They are mutually interacting bodies. So total linear momenta is m1 u1 plus m2 u2. And they are mutually interacting bodies, external forces are not acting. They are mutually interacting bodies. Yeah? So after collision, their linear momenta will be m1 v1 plus m2 v2. According to principle of conservation of linear momentum, m1 u1 plus m2 u2 must be equal to m1 v1 plus m2 v2. So you will have m1 u1 plus m2 u2, this is equal to m1 v1 plus m2 v2. Total linear momenta of mutually interacting bodies will remain conserved if no net external force will act on mutually interacting bodies. Come back here. Now, according to Newton's third law is this: multiply F21 from time minus F12 and time, the time for which this collision had taken place. Correct now? So what it becomes? F21 del T is impulse acting on body 2. So this is L2 and this is minus L1. F21 is force acting on body 2 due to 1. The force acting on body 2, if you multiply by time, that will become impulse acting on body 2. And F12 is force acting on body 1 due to 2. You are multiplying it by time, that will be impulse acting on body 1. Clear to you? Now, impulse is change of linear momentum. Right now, if you take L2, this will become M2 V2 minus M2 U2. Impulse is change of linear momentum L2, change of linear momentum of body 2. How much it is? M2 V2 minus M2 U2. This must be equal to minus of change of linear momentum of body 1. So this will be equal to M1 V1 minus M1 U1. Understanding now? Impulse is equal to, I have taught you, change of linear momentum. The impulse for body 2 will be change of linear momentum of body 2. Change is always final minus initial. Your final linear momentum of body 2 is M2 V2. Initial linear momentum is M2 U2. L1, change of linear momentum of body 1. So it is M1 V1 minus M1 U1. Break it. So, or you are getting M2 V2 minus M2 U2 equal to minus M1 V1 plus M1 U1. Clear? Or M1 U1, I am taking this M2 U2 that side, so plus M2 U2, M1 V1 I am bringing this side, M1 V1 plus M2 V2. This you check, is it same? Yes or no? You have derived, you have proved. When no net external force will act on the body, mutually interacting bodies, then total linear momenta of those two mutually interacting bodies will always remain constant. We have started from Newton's third law. We have gone on impulse. We have taken definition of impulse as change of linear momentum, and we have derived it. Is it clear to you? If you understood this, further about this we will be talking later on. You can go even so many ways to derive beta. I can go for F equal to dP by dt. In one line we can derive. If they say no net external force is acting. Okay, no? The F is 0. dP is 0. Now integrate. Okay, no? P will remain constant. Differentiation of constant is 0, so integration of 0 will be constant. P will be constant. No need to derive this much. In one line you can directly say. Right now? But leave that. We don't know at this time differentiation, integration and all. No. When you will be coming now, very soon you will be here. Okay, no? At that time in depth we will be learning. Right now? At this time the classical technique to derive. Actually in intermediate exam when they will ask you this type of question, 4 mark short answer question they will ask you, BVI for intermediate examination, this derivation, so you will be deriving like this. Is it clear to you? Let us now move to now class work and all. Okay, about free body diagram, tension, normal reaction, all I'll be telling you in incoming days, tomorrow, day after tomorrow and all, we'll be learning those things. Now, we are going for class work. momentum has the same unit as. But if velocity I am taking meter per second, the change of velocity, what will be the unit? Meter per second, na? Yes or no? If they say momentum has the same unit, what is impulse? Change of linear momentum, no? So whatever will be the unit for momentum, kilogram meter per second, that will be the unit for change of linear momentum. Kilogram meter per second in SI, International System of Unit. Impulse is change of linear momentum. Right now, other quantities are the big torque, moment of force, both are same thing. Moment of force and torque, they are same. Couple is also same. Torque due to couple, torque, moment of force, all three will have same unit, F into R, same dimensional formula. Here, momentum has the same unit, that of impulse. Why? Impulse is change of linear momentum. Clear to you? What will be the unit? Tell me in SI. Kilogram meter per second. Now, let us move to next question. When a force of 1 Newton, from here mathematical part starts, force is 1 Newton, mass is 1 kilogram, which can move freely, the object moves with. So force equal to beta mass into acceleration. So acceleration will be equal to force by mass. SI unit beta 1 Newton by 1 kilogram. How much it will become? 1 meter per second squared. I have defined force yesterday only. If Newton also I have defined, na? If a force acts on the body of mass 1 kilogram, and if it is producing an acceleration of 1 meter per second squared along its line of action, then we say that force acting on the body is 1 Newton. So here you can check acceleration, how much you got? 1 meter per second squared. Is it clear to you? Let us move now to next question. The net force acting on a body of mass 1 kilogram moving with a uniform velocity of 5 meter per second. Cleverly, they are making you fool. Am I right now? They are telling you body is moving with uniform velocity. According to Newton's first law, if body is moving with uniform velocity, it means no force is acting on the body. Yes or no? Newton's first law. Body will be either at rest or body will be moving with constant velocity. When no net force is acting on the body. The problem is the net force acting on the body of mass 1 kilogram, you give 10 kilogram, 100 kilogram, answer will not change. Moving with uniform velocity. The important word is uniform velocity of 5 meter per second. Because body is moving with uniform velocity, so net force will be equal to 0. Answer, no net force is acting on body. Answer is 0 Newton. Acceleration, unless body will not have acceleration, force will be 0. Let us see next question. A body of mass 20 kilogram. Mass they have given you 20 kilogram moves with an acceleration of 2 meter per second squared. The rate of change of linear momentum in SI unit is. Rate of change of linear momentum is known as force according to Newton's second law. Yes or no? Yeah? Means indirectly they are asking you force. They are asking you rate of change of linear momentum na. Rate of change of linear momentum is force, and force is mass into acceleration. So my force, this is mass into acceleration, 20 into 2, guaranteed it will be Newton SI. Answer 40 Newton. Answer is A. Check. Recollect Newton's second law, fundamental law. Okay, no? The rate of change of linear momentum is nothing but force, F equal to dp by dt. They are asking you dp by dt, means they are asking you force. And force is m into A. Simply multiply it. Answer is ready. Now, let us move to next question. A body of mass m strikes against a wall with a velocity v and rebound with the same velocity. No. Direction will be reversed. Rebound with the same speed. What is change in momentum? So suppose I have a wall. This is a wall. This is a body of mass m. It is moving with velocity v. It has a hit. I'm taking it positive x direction. This direction means plus I in terms of unit vector. Okay, no? And it is rebounding with same speed. Now, this is minus v beta, because it is moving in negative x direction. Velocity is a vector quantity. Linear momentum is also a vector quantity. And I have taught you change of linear momentum, not only change of linear momentum, change of displacement, change of velocity, change of acceleration. Anything you take, change is always equal to final value, final minus initial. Right? No. Change of velocity, v final minus v initial, vector subtraction. The linear momentum is also a vector quantity. The change of linear momentum, I always say beta linear momentum, not momentum. You will tell, why sir? We have angular momentum also, na? If you say momentum, so which momentum? Are you talking about linear or angular? So better, why to be confused, call it linear momentum. So what is change in momentum? The change of momentum, del P is P final minus P initial. Okay, beta? P final is minus MB, right? And it is minus mv. It is minus 2mv. Check. Your answer is minus 2mv. Magnitude part is 2mv and direction is away from the wall. If I will take towards the wall positive x direction and we are considering unit vector plus I cap, then here answer will be 2mv minus I cap. I am writing that 2mv minus I cap. If you take this direction plus I, then this direction will be minus I, na? Understanding, no? Clear to you? Now, let us move to next question. Gram weight is a unit for. But a gram weight, you take a body of mass 1 gram, right? No? With whatever force, Earth will pull the body of mass 1 gram towards a center. That force is known as 1 gram weight. Okay? So this is the unit for force, weight of the body. 1 kilogram weight, if I want, then I will be taking 1 kilogram into 9.8, means 9.8 Newton. When you are taking your weight on a weighing machine, you are telling, my weight is 60 kilogram. You are 100% wrong. Why you are wrong? 60 kilogram is the unit for mass. Weight is a force. Actually, you want to say, my weight is 60 kilogram weight. In SI, you want to say, you should multiply 60 from 9.8. If I take approximately 10, I will say, my weight is 600 Newton. Or 60 into 9.8 Newton. The 1 kilogram weight is 1 kilogram into 9.8 Newton. 1 gram weight, 1 gram into G. In CJ system, it is 980 centimeter per second square. You'll have to multiply from 980. Here, simple question they had asked you, gram weight is a unit for, and answer will be weight. It is not the unit for mass. Let us move to next question. 9.8 Newton, just now I have explained to you, na? 1 kilogram weight is 1 kilogram multiplied by 9.8. And then it will become Newton. So 9.8 Newton is equal to 1 kilogram weight. Is it clear to you? Next question. A body of mass 5 kilogram undergoes. The mass they have given you 5 kilogram. It is undergoing a change in speed from 20 meters per second. The initial velocity is 20 meters per second and final velocity is 0.20 meter per second. The momentum increases by. Momentum decreases by. Okay? So they are asking you change of linear momentum. The change of linear momentum del P will be equal to always final minus initial 5 and it is 0.2 minus 20. How much you are getting? You are getting minus 5 into 20.2 you will subtract 19.8. Okay, unit kilogram meter per second. How much you are getting? Check. You are getting 99 kilogram meter per second. Clear to you? So, they are telling you what is the change of linear momentum. Minus sign is indicating that it is decreasing. Okay, no. It has decreased by 99 kilogram meter per second. Check answer. It has decreased by 99 kilogram meter per second. Next, not there, all class work I have completed. I'll continue because classwork you have completed. So after this, you will have homework. I'll first complete homework and further teaching will be continued. I will be introducing the concept of normal reaction, free body diagram in brief. Okay, basic concept. Okay, no, tension, and then based on them, if there will be some problems in our CBC book, we will be doing that. Thank you to all of you. Time is over now. Okay? Have a nice day. Now, 10-minute break you would have. After that, your math class will start. Again, have a nice day. Thank you.
रिकॉर्ड करूँ. Good morning, students. So yesterday we have discussed sets and we have completed a sequence series. So today we'll be discussing questions based on set. Yesterday we have seen the definition of set and types of set, right? Types of set. Okay, so let's start. I hope you have done the question, and the questions were very simple. So what is the first question? State whether the following collections are a set or not, right? The collection of a natural number between 2 and 20, right? Collection of natural number between 2 and 20. If I write, right, 2 and 20, I can write all the numbers between 2 and 20. So it is a well-defined collection of numbers, right? So it's a set, right? Second, the collection of numbers satisfying the equation x square minus 5x plus 6 equal to 0, right? So x square minus 5x plus 6 equal to 0. There will be two numbers, 2 and 3, right? So again, it is also well defined, so it will also be a set. Correct. Next, the collection of prime numbers between 1 and 100. We can write all the numbers between 1 and 100, right? We can list all the numbers from 1 and 100, so it can start from 2 and it will be ending at what? 99. So again, it will also be a set, right? Then fourth, the collection of all the beautiful women in Jalandhar, right? Now this word beautiful, okay, is subjective. For some people, there could be some criteria of beautiful. For some people, there could be some criteria of beautiful. So it is subjective, right? It is not well defined. All right. So that's why this fourth one will not be classified as what? Set. Understood? So fourth one will not be a set, but the above three statements will be what? A set. All right. Okay. Next. Write the following set in the tabular form, right? Write the following set in the tabular form. So if I want to write this following set in tabular form, what it will be? It will be A equal to x is what? Positive prime less than 10, right? Positive prime less than 10 means 2, 3, 5, 7, right? 9 is not a prime number, so 2, 3, 5, 7. Okay, so A is this. And what about B? B, they are saying x is equal to 3 lambda. X is equal to 3 lambda. And lambda belongs to what? 1 to 3, right? X is equal to 3 lambda, and lambda belongs to what? 1 to 3. So if lambda is between 1 to 3, right? So if I put lambda equal to 1, what I'll get? X as 3. If I put lambda equal to 2, what I'll get? X as 6, right? If I put lambda equal to 3, what I'll get? X as 9, right? 3, 6, and 9. So can I say the set B? Set B will be what? 3, 6, 9, right? 3, 6, 9. Okay? I hope this is clear to everyone. Next, write the following set in set builder form, right? Write the following set in set builder form. So 0, 7, 26, 63, 124, 215. What is so common in between them is that, see, 0 is written as what? 1 cube minus 1, right? 7 is written as what? 2 cube minus 1. 26 is what? 3 cube minus 1, right? And this is continuing, right? So what can I say? I can say that this set A is x such that x cube minus 1, right? X is what? Such that x is x cube minus 1, or we can also say lambda cube. X is equal to what? Lambda cube minus 1, where lambda belongs to natural number, right? X is such that x is equal to lambda cube minus 1, and lambda belongs to what? Natural number. Okay, so this can be classified as what? Set builder form. Okay, and then 2, 5, 10, right? 2, 5, and 10. So 2 can be written as what? 2 can be written as 1 square plus 1. 5 can be written as what? 2 square plus 1. 10 can be written as what? 3 square plus 1, right? So again, by the same logic, can I say this will be equal to B is equal to what? X is such that x is equal to lambda square plus 1. Lambda belongs to what? Natural number, right? X is equal to what? Lambda square plus 1. This belongs to what? Lambda square plus 1, right? So this is what we have written in set builder form. Okay, I hope this is clear to everyone. Fourth question. Express the set A equal to x such that x belongs to natural number and x is equal to what? 2 to the power n, right? Express set A equal to what? X to the power n, and x is equal to 2 to the power n for n belongs to natural number in roster form, right? In roster form. So how will I write in roster form? I will start putting the value of n. So it is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and so on, right? And so on. So if I want to write it down, right? If I want to write it in the number format, it will be what? 2, 4, 8, 16, so on, right? 2, 4, 8, 16, so on. Understood? This is what? This is, we have written this set A in roster format. Okay? I hope this is clear to everyone. Just we have plugged in the value of n here and we have got the answer. Correct? Okay. Next. 5. Express set B is equal to x cube is such that x is less than 5. X cube such that x is less than 5 and x belongs to what? Whole number. X belongs to whole number in roster form. Right? So set B is equal to x cube such that x is less than 5. Right? So we will first start with the whole number as what? 0. 0 cube is 0 only. Then 1 cube is also 1 only. Then 2 cube will be what? 8. 3 cube will be what? 27. Right? 4 cube will be what? 64. Right? And we'll stop it here. Right? We'll stop it here because x has to be less than 5. If I take x equal to 5, it will give me 125, but x cannot be greater than 5. Right? So that is why this has to be what? Rejected. Okay? So this is the set expressed in what? Roster form. Next, question number 6. If A is equal to x belongs to natural number, x square is less than equal to 36, then A is equal to what? Right? They are saying x is a natural number and x square is less than equal to 36, right? X square is less than equal to 36. So if it is a natural number, I will start putting x is equal to what? 1, right? Then I'll get 2. I'll put 2, I'll get 2 square. Correct? So x of x square should be less than equal to 36, right? So what will be the number will be coming, right? It will be coming as, it is a natural number, so this can't come because it has 0, right? What about this 6? 6 cannot be coming because it is just equal to 6, right? And this is what? Minus 6, minus 5, minus 1, 0, 1, 2, 6. But they have said x is what? Natural number. So that's why this also has to be what? Rejected. So the correct answer for this is what? Option A, right? The correct option for this is what? Option A. Why? Because this has to be a natural number and x square of that should be less than or equal to what? 36. Understood? All right. 7th question. Write x is equal to 1, 4, 9, 16, 25 in set builder form, right? So you can just clearly see 1, 4, 9, 16, 25 are all what? Squares of natural numbers, right? Are squares of natural number. All the other square of natural number, right? So the x is a set of prime numbers, it is wrong, right? X is a set of whole number, again wrong. X is a set of natural number, again wrong. X is such that x is a set of squares of natural number, right? As we have discussed, this is the correct statement, right? As we have discussed, this is the what? Correct statement. All right? I hope this is clear to everyone. Next. 8th, the set O of positive integers less than 10 can be expressed here. O of odd positive integer. They have said odd positive integer less than 10, right? It is clearly saying odd positive integers. So how can 2 come here? That is why this will not be the answer. Again, 2 is there, not answer, right? In this case, this can be an answer, but they are saying less than 10, right? But it has 11. So that's why this cannot also be the answer. So the correct answer for this is what? Option B, right? The correct option for this is what? Option B. All right? I hope this is clear to everyone. These questions are very simple, just understanding based. There should not be much doubt in this question. Just we are discussing it so that you get a clear understanding about it. Right? The members of the set S is equal to x is such that x is the square of an integer and x is less than 100, right? They were saying x is a square of an integer less than 100. Now, integer, they are saying, clearly saying it is square of an integer. In integer, 0 will also come, right? So if 0 is also coming, so C is already rejected. Why? Because in C there is no 0. Correct? C there is no 0, right? Then, now 0, 2, 4, 5, 9. These are not squares. 2, 4, 5, 9. So this is also, option A is also rejected, right? Option A is also rejected. Now comes option B. Option B, if I see, the only difference between option B and option D is, I guess, 81 and 121, right? Rest all the numbers are what? Same, right? But 81, 81 is less than 100 and 121 is more than 100, right? So that's why this option D has to be rejected and option B has to be selected, right? Option B has to be what? Selected, because that is the square of an integer less than 100, right? This is all the squares of integer less than 100. Okay, okay. Let's go to the next one, 10th. The number of elements in the set X such that X is a letter of the word trigonometry. X is a letter of the word trigonometry, right? Now, how many letters are there in this this word trigonometry, right? So let's see here. T, R, I, G, O, N, O, M, right? E, T, R, Y, right? So as I have discussed, it has to be distinct, right? The letters has to be what? Distinct. Repeated letters, there is no point, right? So if I just see the distinct part, I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? How many distinct are there? 10 are there. Right? Distinct letters are how many? 10. So the correct answer for this is what? 10. Understood? I guess nothing is. This T is repeated. Sorry, T is repeated. So T will be coming here. So instead of 10, the answer will be what? 9. Right? T is been repeated here twice. So that's why the correct answer will be what? 9. Understood? Okay. I hope this is clear to everyone. Now let's go to the next one. Write the set X such that X is a natural number and X square minus 9 equal to 0, right? X is a natural number and X square minus 9 is 0. So see, this is not a natural number, rejected. This is not a, this contain minus h is not a natural number, so this is also rejected. This is what? 9 and 3, but X square minus 9 equal to 0, right? So this is also wrong. So the correct answer for this is what? Option A, right? The correct option for this is what? Option A. Okay, I hope this is clear to everyone. Just give me a minute. Okay, let's go to the next one, 12th, right? What is the solution set of the equation x square plus 3x plus 2 equal to 0 in roster form, right? So if I try to solve this, what will I get? X square plus 3x plus 2 equal to 0, right? So what I will get? X square plus 2x plus x plus 2 equal to 0. I can take x common, so I'll get x plus 2 plus 1, x plus 2 is equal to 0. So I will get x plus 1 into x plus 2 is equal to 0. It means that I will have x is equal to minus 1 or x equal to minus 2. Right? X equal to minus 1 and x equal to minus 2. So which option has this option? Option B, right? In this there is a minus 1 and 2 is wrong, 1 and minus 2 wrong, 1 and 2 is also wrong. So the correct answer is what? Option B. Alright, I hope this is clear to everyone. 12th question. 13th. Which of the following is not a set of the letter of the word principal? Right? Principal. Alright. So in principle, see, in option C, what is there? There are two P repeating, which is cannot be there. We do not write a repeated letters in a set, right? Now, what is the problem in option C, A, C, D? We need to see, right? So what I'll write? I will see what are the letters repeating here. Which of the following is not a set? So they are asking not a set, right? So all the three are the correct one. So this is only the not the set of the That is why for this question the answer is what? C. Right? They are asking not a set, because all these three are actually what? Set, just the order in the which the elements are written in this is what? Not proper. So that is why the answer is what? C. Right? Because in this there are 2 times C is coming. Okay. All right. Next question. Which of the following does not belongs to a set X such that X is a vowel in the English alphabet, right? So what are the vowels in the English alphabet? A, E, I, O, U, right? A, E, I, O, U, right? So E is right, I is right, D is right. So which of the following is not there? So answer is B, right? B is the set, B is the element which is not there in the English alphabet, right? I hope all of you know this, that this is the elements in the vowels in the English alphabet. Okay. 15th. Which one of the following is not a set? Which one of the following is not a set? So, A, the collection of a whole number less than 200, the collection of all the boys in your class, the collection of all talented actors in Hollywood, the collection of all the books written by Chetan Bhagat. Okay. Now, let's see them one by one. The collection of all the whole number less than 100. Yes, definitely it's a set, because we can write it from 0, 1, 2 till 199. Right? So this will be a set. Right? They're asking not a set. So this can't be the answer for this question. Then collection of all boys in your class. Definitely this can also be a set, because being a boy is not subjective, right? Either someone is a boy or a girl. Definitely it is a well-defined thing. Next, the collection of talented actors in Hollywood, right? This talented word is subjective to everyone, right? Talented is different for every person. So this cannot be a set, right? This is not a well-defined particular thing. Okay. Next, option D, the collection of all books written by Chetan Bhagat. This is also a set. Why? Because the books written by Chetan Bhagat will be well defined. We will be getting to know which are the books will be written by Chetan Bhagat, right? Any author, if I just, any book if I open, I will definitely get to know which are the books written by Chetan Bhagat. So this is also well defined. All right. So the correct answer for this is what? Option C. Right? The correct answer for this is what? Option C. Okay. I hope this is clear to everyone. Okay, now this is worksheet number 13. I think yesterday we have discussed some part of it. First we will discuss the theory for this one, right? There is some part of it which is remaining, and then we will discuss it today itself, right? Worksheet number 13. Okay, so first we'll discuss the theory. Just give me a minute. Theory of this, right? Okay. So, subset, superset and proper subset, right? Subset. First, we'll understand what is a subset, right? Yesterday we have discussed empty set, null set, singleton set, finite set, infinite set. So these are further classification of what a set, right? Now, what is a subset of any set, right? What is a subset of any set? The definition says, let A and B be two sets. Let A and B be two sets, and if every element of A is an element of set B, right? That is A belongs to B, right? And also obviously A belongs to A. Then we say that A is a subset of B. Then we say that A is a subset of B. Okay, this is a sign of what? Subset. A is a subset of B, right? So if you know what is a Venn diagram, right? So what is a Venn diagram? In this, let's say this is a bigger set, B, right? This is a bigger set, and there is a set A inside this, right? There is a set A inside this, right? A inside this. So this part, right, since A is completely lying inside B, then we'll say that A is a subset of B, right? Then we say that A is a subset of B. Understood? For example, let's say Hyderabad. Hyderabad is a subset of what? Telangana, right? Because every citizen of Hyderabad will be a citizen of what? Telangana, right? Telangana is a subset of what? India, right? So that is why we will say that Hyderabad is a subset of Telangana, right? Now what does B is called, right? So in this, A is called subset, right? A is called what? Subset, and B, which is the bigger one, it is called superset of A, right? This is the next topic. It is called what? Superset of A, right? The one in which A is completely lying is called superset. Okay. So this is a definition of what? Subset. Okay. I hope this is clear to everyone. What is the meaning of subset, right? Okay. And if A is not a subset of B, then we write A is not a subset of B, right? If I want to write, if A is not a subset of B, A is not a subset of B, then we have to write it in this way, that A is not a subset of what? B. Understood? Okay. Next. Now there are some results on subset. We will understand them one by one. I'll write it here. Some results. Some results on subsets. Right, some results on subset. So what is the first result? First is every set is a subset of itself. Right? Every set is a subset of what? Itself. Second, right? Because definitely every element of a particular set will be belonging to that set. That's why it is called subset of that particular set. Right? That is, I can say that A is a subset of set A. Right? Okay. Next. Then empty set. The empty set is also a subset. Is a subset of every set. Right? Empty set is a subset of what? Every set. Understood? Third is the total number of subset. The total number of subset, right? The total number of subset of a finite set. Of a finite set containing n elements is equal to what? 2 to the power n. Right? Is equal to what? 2 to the power n. So for example, let's say A is what? 1, 2, 3. Right? A is what? 1, 2, 3. And if I want to find out total number of subset, how many are total number of possible subset of this particular set A? Right? So what I can write down? Right? Total number will be how much? Total number from this formula will be 2 to the power 3, which is what? 8. Right? 2 to the power 3. And which sets will be that? So see, it will be, first we'll write single set. So 1, 2, 3. Then we will write the pairing sets. Right? Then we'll write, so before this there is one more set. Before this there is one more set. Right? Which one? Empty set. Right? Before this there is one more set. Empty set. Just a minute. So if A is this, right? So I can write 5, 1, 2, 3. Then we'll write pair of this. Right? Then I'll write 1 and 3. And at last, I will write this set itself. Right? So if I write this set, I'll get 1, 2, and 3. Correct? So total number of set are how many in this particular set? Total number of set are, this is 1, 2, 3, 4, 5, 6, 7, and 8. That is why the number is what? 8. Okay? So I hope this is clear to everyone. There are total number of subset of a finite set containing n elements, right? Containing n elements is how much? 2 to the power n. Okay? Alright. Next statement, fourth. The total number of non-empty subsets of a finite set containing n elements will be equal to what? 2 to the power n minus 1, right? 2 to the power n minus 1, right? Because so for example, let's say A is what? Again, I'll write 1, 2, and 3. So if I want to write the non-empty subset of this, right? Non-empty subset. So what are the possibilities? We will write first 1, then 2, then 3, then 1 comma 2, right? Then 2 comma 3, then 1 comma 3, and then 1, 2, and 3, right? Then 1, 2, and 3. So how many total possible subsets are there? Total are how many? 7, right? Total are how many? 7, which is what? 2 cube minus 1, right? 2 cube minus 1. Why? Because we have removed the empty set from here, right? This has been removed. Understood? Because they are clearly saying it has to be what? Non-empty subsets, right? They are asking clearly non-empty subsets. Okay? Alright, I hope this is clear to everyone, right? This is the fourth point about subset. Next we'll do superset. As I have already explained what is the superset, I'll just write the definition of this superset. So as I have given the example that Hyderabad is a subset of what? Telangana. So Telangana will be called as a superset of B. The set which contains the subset, right, is called what? Superset. Alright. So let's write the definition. The definition says a set A is said to be superset of set B, right, if B is a subset of A. If B is a subset of A, right, that is each element of B is an element of set A, right? As I have mentioned that suppose if B is the subset of set A, then B is called what? Subset, right? And A is called what? Superset, right? A is called what? Superset. So please remember this or about this part. Okay, now let's go to the next part. Now let's see a few examples of this, right? Example. So first is what? A is not a subset of B, C, A. We need to know it is true or false, right? A is not a subset of B, C, A. Second, X comma P, right? X comma P is not a subset of X such that X is a consonant in English alphabet. Right? Okay. Then 3, alpha, beta, gamma, delta is a subset of alpha, beta, phi and psi. Okay. Fourth, A comma B is a subset of, right, A comma B is a subset of A, B and C, right? Examine whether this A, they are saying it is belongs to, right? A comma B belongs to this, okay? All right, so let's examine them one by one, whether they are true or false. The first one, what they are saying, A is not a subset of BCA, right? Since only A is not a subset of BCA, which is a wrong statement, right? Because A is clearly a subset of what? BCA, so that is why it is not a correct statement. Then X comma P is not a subset of what? X, such that X is a consonant in English alphabet, right? If I want to write the consonant, definitely X and P will be coming in it, right? So it will also be a part of the consonant set, right? That is why this second statement is also what? Not correct. Okay, then let's do third. Third, what it is saying, alpha, beta, gamma, delta is a subset of alpha, beta, phi and psi, right? This is not, because phi and psi is not present in this case, right? This gamma delta is something different. Again, this is also incorrect, right? This is also incorrect. Now, next is what? A comma B belongs to, A comma B belongs to this, right? A comma B doesn't belong to this. A comma B is a subset of this, right? A comma B is not an element of this particular thing, right? A is an element, B is an element, but A comma B is not an element of this particular set, right? This sign means what? Belongs to, right? So basically this is not correct. Again, this is also what? Not correct. So all the statements were not correct in this case, right? That is why it is so, we have already understood this part. Okay. Okay, let's go to the next part. Next part is saying if S is equal to what? 0, 1, 2, 3, right? Then total number of subset of S is equal to what? Right? Total number of subset of S is equal to what? Right? So I have given you the formula. What is the formula for total number of subset? The formula is 2 to the power n, right? 2 to the power n. And what is n of S? N of S is how much? 4, right? How many elements are there in this? 4 elements are there. So total number of subset of S will be equal to what? Directly 2 to the power 4, right? Which will be equal to what? 16. Right, which will be equal to what? 16. And if they ask you total number of non-empty subset, right? Then it will be what? 2 to the power 4 minus 1, which will be what? 15, right? 2 to the power 4 minus 1, which will be what? 15. Understood? And if I want to list down all the particular subsets, so what will be it with? First will be coming as empty set, right? Then 0, then 1, then 2, and then 3, right? Then their pairs will be coming, so 0, 1, right? 1, 2, 2, 3, right? Then 0, 3, and 1, 3, right? Then in 3, if I want to write down, then 0, 1, 2, then 1, 2, 3, then 0, 1, 3, right? And then one more will be coming as what? 0, 2, 3, right? 0, 2, and 3, right? And at last, which one will be coming? All the 0, 1, 2, and 3, right? So these are all the particular subsets of set S, right? If I want to count them, how many it will be? How many it will be? This is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I think we missed one. We missed one here, right? There has to be one more. So if I want to write 0, 3, I think 0, 2 we have not written. Yes, 0, 2. Right? Now if I count, it will be what? 16 sets. Understood? Okay, I hope this is clear to everyone. Then next part. Okay, next part is what? Power set. Right? Power set. Next part is what? Power set. Right? Then what is the definition of power set? The collection of all the possible subsets of any set A, right, is called power set. Is called power set of set A. Right, is called power set of set A, and it is written as what? P of A. It is written as what? P of A. So for example, let's say A is equal to what? 1, 2, 3. Right? And if I want to write the power set of A, right? Power set of A. So we have to write, basically we have to write all the possible subset of A. So, right? So it will, we have already written that. First will be 5, then 1, then 2, then 3, right? Then 1, 2, then 2, 3, and then 1, 3, right? And then will be what? 1, 2, and 3, all of them, right? So what are the total number of possible subsets of A? Right? This will be 8. Understood? Okay. And number of elements in power set of A will be what? 2 to the power n only, right? Because it is equal to what? Total number of possible subset. So that is why it is equal to what? 2 to the power n. So you can see here, this is 4, this is 3, and this is 1. So it is how much? 8. So it is why 2 to the power 3, and which is what? 8. Right? Which is what? 8. So this is what the power set of any possible set A is defined as, right? Number of elements in set is defined as this. Okay? I hope this is clear to everyone. Right? What is the power set of any particular set? Okay? We'll practice questions on this, and then we'll be discussing the worksheet. Right? Okay. Now what they are saying, number of subset of power set, number of subset of power set of set A if n of A is equal to 2, right? If n of A is equal to what? 2. So number of subset of power set, right? So how many elements will be there in power set? Right? In power set, how many elements will be there? N of P of A will be how much? 2 to the power 2, right? Which will how much? 4, right? Now they are asking number of possible subset of this set. Let's say this set is what? B. This is N of B, right? They are asking number of elements in power set of B, which will be how much? 2 to the power 4, which will be equal to what? 16, right? Which will be equal to what? 16. So that is why the correct answer for this question is what? 16. Okay. All right. Let's do the next one. Next is, we need to write down P of phi, right? First thing. Second, we need to write down P of phi. Third, we need to write down, right, number of elements in P of phi, right? And last, fourth, number of elements in P of phi, right? First, what are the number of, what is the power set of phi, right? Power set of, so in phi, how many elements are there? 1, right? So it will be like this. Either it will be phi or it will be phi. Understood? Because phi itself contain no element, right? So it will be what? Power set of phi will be equal to what? This. Understood? Wait a minute. No, this, for this it is not this. This will, it will be power set of phi will be what? phi only, right? Either this we can write or option as phi, or, right? Because phi contain how many elements? 0 elements, right? So in its power set, how many elements should be there? 2 to the power 0, which is 1, right? 2 to the power 0, which is 1. Okay, all right. Next, so it should be coming like this, or like this. Okay, next, power set of phi, right? So it means this one will contain how many elements? It will be containing phi or phi, right? Because this contain how many elements? This particle contains 1 element, right? So number of elements in its power set will be how much? 2 to the power 1, which will be what? 2. Correct? Now, what are they saying? They are asking the number of elements in the power set of this, right? Number of elements in the power set of this, right? So this we already know how many elements are there in this one. In this there are 2 elements, right? How many elements? 2. So n of p of 2 will be how much? 2 to the power 2, which will be what? 4, right? Which will be how much? 4. And we already found the elements in this now. Here it is how much? 4. So its power set will contain how many elements? Power set will contain 2 to the power 4, which is how much? 16 elements, right? Its power set will be containing how many elements? 2 to the power 4, which is 16 elements. Understood? Because this inside thing contain 4 elements. We have just proved it here. All right? I hope this is clear to everyone. Okay, now let's come back to the worksheet number 13. We have cleared the theory of this. Now we'll be doing the worksheet number 13, which we have stopped in the middle, right? Okay. What is the cardinal number of a set defined by this, right? What is the cardinal number of a set defined by x is a prime number and divisible by 7, right? It is a prime number and divisible by 7, right? If a number is divisible by 7, then how it can be a prime number, right? How it can be a prime number, right? So that is why it will contain no elements. It will contain no element, right? Or we can say x is a prime number and divisible by 7. 7 itself will be divisible by 7. There will be only one element in this, not 5. There will be only one element in this, which is 7, right? 7. So that is why the cardinal number of this will be what? 1. Right? Cardinal number of this set will be how much? 1. Because 7 itself is divisible by 7 and 7 is a prime number. There is no other prime number, right, which is divisible by 7 also and it's a prime number also, right? So the answer is what for this? 1. Okay. Next. Which of the following is a not an empty set? Not an empty set, right? X is a prime number and x is lying between 7 to 10, right? If x is a prime number between 7 to 10, I can say x is equal to 9, right? So it is not an empty set, right? There is no prime number between 7 to 10, right? So 8 is not a prime number, right? 9 is also not a prime number, right? And there is nothing between other than this, correct? So that's why this will be an empty set, right? This will be an empty set, correct? Okay. Now, x square is minus 10, x is a real number. Again, this is also an empty set because there is no real number for which the square of it can give me a negative number, right? Square of which can give me a negative number. So this is also an empty set. Then x is less than 1 and x is greater than 4, right? How can a number, any number x, can be simultaneously x greater less than 1 also and more than 4 also. So this is also what? This is also what? An empty set. Now let's see the last number, right? X square equal to 4, x is a natural number. X square equal to 4, x is a natural number. So is there any natural number whose square is 4? Yes. It is what? 2. There is a natural number whose square is what? 4, which is 2. So that's why it will contain one element, right? This will contain how many elements? One element. That is why this is not an empty set. They have asked which of the following is not an empty set, right? So the answer for this will be what? Option D. Okay. All right. Next. if A is equal to X such that X belongs to natural number and X is lying between 5 to 6, right? X is lying between 5 to 6. X cannot be, there is no natural number between 5 to 6. So definitely it is a null set, right? There is no natural number between 5 to 6. That is why it is what a null set. Understood? Okay. The set of intelligent students in the class is, right? Again, intelligent is not a well-defined thing, right? Intelligent is not a well-defined thing, so we'll say that it is not a set itself, right? It is not a well-defined term, because for some people intelligent can be more than 90%, for some people intelligent can be more than 80%, right? Or 95, whatever. So it is a subjective term, that is why it is not a well-defined term, right? This is incorrect, this is incorrect, and this is also incorrect. So the answer is what? Not a well-defined collection. Okay, next. The set A is equal to X such that X belongs to R and X square is equal to 16 and 2X is equal to 6, right? X square equal to what? 16 and 2X equal to 6, right? So if I solve this 2X equal to 6, I will get what? X is equal to 3, right? X is equal to 3. And if I solve this X square equal to 16, I will get X is equal to plus and minus 4, right? X is equal to what? Plus and minus 4. So there is no common value between this and this, right? There is no common value between this and this. That is why we will say it is not a, it is a null set. There is no common value between 3, minus 4 and 4. So that is why it is what? A null set. It is well defined, but it is not a set. There is no element in the set. Understood? Okay. Which of the following set is an infinite set, right? Which of the following set is an infinite set, right? So set of divisors of 24, set of divisors of 24. How many divisors are there? 24. We can list it, right? What are there? 1, 2, 3, 6, 12, and then 24, right? 1, 2, 3. I think I missed anything. We missed few. It will be 4 also, right? 4, then 8, right? But still it will be what? Finite set. It cannot be infinite. Understood? Then set of all real numbers which lies between 1 and 2, right? Set of all real numbers which is lying between 1 and 2. This is an infinite set, right? This is an infinite set. Why? Because between any two numbers, right, there can be infinite real numbers. Okay. Now set of all human beings living in India. Again, this is a finite set, right? This is a finite set, okay? And set of all 3-digit natural number. This is also a finite set, right? So the answer for this is what? B. This is finite and this is finite, right? Human beings living in India is a big number, but definitely it is not infinite. Not infinite people are living in India, right? We generally say that the population of India is 1.4 billion right now, right? So it's approximately 1.4 billion. It could be somewhere 1.5 also, but it cannot be infinite. Infinite is a very big number, right? So infinite, it is not a infinite set. So the correct answer for this is what? Option B. Between any two numbers, there are infinite real numbers. That is true. Okay? I hope this is clear to everyone. Which of the following set is finite, right? Which of the following set is finite, right? So the first one they are given 1, 2, 3, 4, right? B they have given 4, 7, 9, and this is, I think there is dot 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 in this, in all the three, right? So this is also not a finite one. This is also not finite. This is also not finite. Only 4, 7, 9, right? 4, 7, 9. This will be what? Finite. Understood? So this is self-explanatory. There is nothing to explain it here. 8th, the finite set can have number of elements, right? Finite set can have only 0, only 1, at least 1, 0 or more, but not infinite, right? It is not compulsory that in any finite set there has to be only 0 elements, right? So this is incorrect, right? Again, in option B also there is not compulsory, there is only 1 element, again incorrect. At least 1 element, it is also incorrect, right? At least 1. There can be a 0 element in a finite set also, right? And at D what it is saying, 0 or more, but not infinite, right? This is the correct statement, right? It is clearly saying it is not infinite, but it can be 0 also or more also. Understood? So the right answer for this will be how much? Option D, right? Okay. Next, which of the following is an infinite set, right? Which of the following is an infinite set? A set of girls in a college. A set of girls in a college. In any college, anywhere in the world, right? There cannot be infinite girls. Okay, there has to be a finite number. It will be a big number, maybe if it's a big college, but it cannot be infinite, right? So that is why this is not an infinite set, right? B, a set of players in cricket team. This we already know. It is 11 or 15, right? 11 or 15, depending if they are saying about playing 11 or the total number of player for that match, right? So it is also finite. Then a set of points in a line, right? This is infinite, right? At any line, if I want to see how many points are lying, infinite points are lying, right? So this is a finite set, infinite set, right? And option D, a set of edges in a square, right? If I see a square, right, how many edges are there? It is countable 1, 2, 3, 4, right? So we can say there are 4, so it is finite. Again, this is also incorrect. So the answer is what for this? C. Please remember that for any line there are infinite points on it, right? How many points are there? Infinite points. Okay. Next, which of the following is true, right? A finite set has infinite number of elements. It is self-contradictory statement. How can a finite set can have an infinite number of elements, right? So it is a self-contradictory statement, so this is wrong, right? Next, an empty set is a finite set. An empty set is a finite set. This is a true statement, right? Why? Because just now we have read the definition that a finite set can contain 0 or more, but not infinite elements, right? So this is a correct statement. Then C, an empty set is neither finite nor infinite, right? An empty set is neither finite nor infinite. Understood? This is a wrong statement. An empty set is a finite set. D, an infinite set has a countable number of elements. This is again self-contradictory, right? How can a infinite means that we cannot count it, right? We cannot measure it. So how can an infinite set have countable number of elements, right? So this is also incorrect. Understood? The answer for this is what? Option B, right? Okay. 11th, which of the following is a null set, right? Which of the following is a null set? X is a natural number and x square is equal to 4, right? Is there a natural number whose square is equal to 4? Yes, there is. So the answer for this is 2. That's why it is not a null set. The answer for this is 2, which is not a null set. Second, B, x is a rational number and x square equal to 2, right? X is a rational number, right? And x square equal to 2. So if I see x square equal to 2, I will get x is equal to root 2 plus or minus root 2, right? So both root 2 and minus root 2 are not rational number, right? So this can be a null set, right? This can be a null set, right? X is a even prime number. We all know what is there is only one even prime number, which is 2. So this is also not a null set. And last, X is the name of the day of the week. Name of the day of the week. We know there are 7 names of the days of the week, right? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, right? So there are 7 days like this, right? So the correct answer for this is this contains 7 elements, but they are asking about null set, right? Null set will be which one? It will be what? Option B, right? So this is incorrect. Understood? Option D is also what? Incorrect. Okay, next. Find the solution to the set X. X is such that X is a natural number and 2x plus 1 equal to 2, right? 2x plus 1 equal to 2, right? So if I write 2x plus 1 equal to 2, I will get 2x equal to 2 minus 1, which is 2x equal to 1, which is x is equal to half, right? X is equal to half. right? But they are saying it is a natural number. So this is not possible, right? So this is incorrect, this is incorrect, this is also incorrect because of this line, right? So the answer should be what? D. I think there is a printing mistake here. D will have this bracket, right? Or maybe a null set, right? D will be having a null set or printing mistake. Or that's why the answer should be what? D here. I guess in your book it must be printed correctly. It should be what? No set, null set. Understood? All right. Next question. Which of the following two sets is equal, right? Which of the following two sets are equal? In equal set, if you remember, all the things will be identical, right? All the things will be identical. So it contains 1, 2, 3, it contains 2, 3, 4. This 4 and 1 is not matching, it is not equal, right? In set B, this 7 is extra. So again, not equal, right? In C, 3, 4, 7 and 7, 4, 3. These are equal. The order has changed, but the sets are what? Equal. Understood? And last D, 1, 2, 7 and 2, 7, 1. Because of this 4, they are not equal, right? So the correct answer for this question is what? Option C. Right? The correct option for this question is what? Option C. All right? I hope it is clear to everyone. Next. Let A be a set of prime numbers less than 6 and B be the set of prime numbers, prime factors of 30, right? And so A and B are what, right? So A and B are what? If I want to write prime numbers less than 6, it is 2, 3 and 5, right? And B, if I want to write the prime factors of 30, right? Prime factors of 30, so it will be again 2, 3 and 5. Understood? There is no other prime factor of what? 30. Understood? So the both of them are what? A and B are what? Equal. They are finite also. They are not infinite. They are not empty. They are not singleton. And they are what? But equal. Right? Both of them are what? Equal. Understood? Okay. Which of the sets are equal? X is equal to X such that X minus 4 equal to 0. And X is a natural number. Y is equal to X square equal to 16 and X is a natural number. And Z equal to X greater than 4 and X is less than 16 is a natural number. Okay, so if I write the first set X in roster form, I'll get 4, right? If I write Y, X square equal to 16, right? X square equal to 16 will give me two numbers. One is 4 and one is minus 4, but they are saying natural number, right? They are saying natural number, so we'll say which one? It's 4, right? And Z what they are saying, X is greater than 4 and X is less than 16. So if I want to write down this, so it will be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, right? So these are all the elements in what? Z, right? Which are more than 4, less than 16 and are what? Natural number. Correct? So this will also not be a, so they are asking which of them are equal sets. So obviously X and Y are equal. The correct answer is what? Option A. B, C and D are what? Not equal, right? They are not the example of equal set. That is why it is not will be there. Correct? Okay, next. Okay, I think the questions are ended. All right. So we have completed a theory today of power set, right? And this. So now we'll be giving you homework on based on this, right? So for today, I think worksheet number 14. Yes, worksheet number 14, right? For today, worksheet number 14 is the homework, right? Worksheet number 14 is page number 74, right? How many questions are there? All 74 and 75. There are only 12 questions, so all 12 questions are homework. Right, all 12 questions are homework for today, right? And please revise it. The sets chapter is very simple. Now from tomorrow it will get little complicated, right? The operations on set, but it is also not very difficult. We'll be doing it, right? So that's it for today, all right? See you next time. Just do this homework for tomorrow, all right? Thank you, everyone.